So if you're here, you're taking a look at lesson unit 4, lesson 6b. This is based on graphs for. So these are for all these different graphs of y is equal to cotan x, tan x, secant x, or cosecant x. So here are some problems that we have that you'll see in today's work. So you're going to find the period, the x-intercepts, and the vertical asymptotes of this problem. Y is equal to tan of 2x. And I should say that we're going to say it's on the interval from 0 to 2 pi. Now, just like before, we start with our basic equation. Y is equal to tan of 2x. Okay, now the one thing that I want you to remember is that when we're calculating the period is always calculated like this. P is equal to 2 pi over k for this unit, right? So when we go and calculate the period for this equation, we're using the k value that we have here. So the period in this case is equal to 2 pi divided by 2, which gives us a period of pi. Now let's go and take a look at the x-intercepts. So for the x-intercepts, what you're looking for is where y is equal to 0 in our original equation. So we just let y is equal to 0, and we have 0 is equal to tan of 2x. Now, here's what you know. For tan, for the original function tan of 2x is equal to 0. So the only way that happens is if 2x is equal to our original description of what our asymptotes were. In this case, our asymptotes are the following. N pi. Okay, and that n pi was for our base graph, right? So remember, the n pi it's n pi, and that gives us our zeros for our graph. But in order to scale it, we have to use this part here, 2x, and we solve for x now. So now when we solve for x, you end up with x is equal to n pi divided by 2, and you have something that looks like this for our zeros. So the zeros are that, and you'd say the x-ints are, well, x is equal to n pi over 2 for n belonging to ints. So now just remember, this n pi that we had here came from the original graph, okay? The original of y is equal to tan of x. So that allows us to find those original zeros. So now that we have that, we can say definitively that my x-ints are basically this. So now to calculate the vertical asymptotes, let's talk about that. All right, so now let's quickly talk about our vertical asymptotes. So for the original vertical asymptotes of tan x, you said that x was equal to, it was n pi over 2. So since we have that, we're going to use for our new graph, we're going to have, instead of y is equal to tan x, we've got y is equal to tan of 2x. Now, here's what we do in order to figure out what our values are. We start by actually writing out this. We actually take this part here, which I'm going to circle in yellow, and we're going to stick it. We're going to say 2x is equal to basically the first asymptote that we have for our graph. So remember, our original asymptotes were at pi over 2. So the first one is at pi divided by 2. And solving, you get x is equal to pi over 4. Now, if I want to know the general points for our graph, for our vertical asymptotes, we're literally going to have to think about what the period is for our graph. Okay, we sat there and calculated it at the beginning. In this case, you're going to have x is equal to, and you're going to say our vertical asymptotes are x is equal to pi over 4 plus whatever the period was for our graph. And in this case, we said our period was pi over 2. So we have to add always n and then pi over 2. And remember that this part here represents the period. So we always start with something and always end with something. And n is equal to, n belongs to integers. And that's it. So now if we graphed it, we're going to have something that looks similar to this. And our graph looks something similar to this. Okay? And we're done. Not much difficulty in that, right? But there is a certain amount of savvy that you have to show when you're doing these calculations. So for this graph, we have y is equal to tan x minus pi over 4. In order to show what actually happens, we have to think about what happened to tan x. So if we had y is equal to tan of x, right? Our original graph has certain features, right? But when we look at the new translated graph, this graph here says we've moved everything to the right by pi over 4. And all you have to do is draw the base graph and then show me what the final graph is. And this is what my graph looks like in the end. And we have our graph looking like this, but originally our graph, it started and ended here. Okay, but all we've just done is we've taken our points and shifted them over exactly pi over 4 units. All right, for this last problem, we're going to find the x-intercepts, the period, the vertical asymptotes for this basic function here. And all we have to do is identify what happens to our graph. So for our graph, we have, I'm not going to do the actual sketch of the graph. You can do that, but I'll show you how to calculate the period, the x-intercepts, and the vertical asymptotes. So for the period, we need to remember that period equals 2 pi over k. And in this case, the k value that's sitting in front of our bracket is 1. So our period is equal to 2 pi over 1, which is just 2 pi. So that is our period. So for our accents, we have something like this. So we've got 0 is equal to quarter and all that business. So really what we're looking at is this. So now we need to find when this happens, okay? So remember, with our original function of cotan of x, our zeros were always pi over 2 plus n pi, okay? And remember, this comes from the original of cotan of x. All right, so now in order to find the other part, we just have to go x minus pi over 2 and solve. So we end up with x is equal to pi over 4 plus n pi for n belonging to integers. Okay, so basically these are our zeros. So the zeros for our graph are given by this. So now let's take a look at the vertical asymptotes. For the vertical asymptotes, you've got y is equal to a quarter of cotan of x minus pi over 2. So just remember that cotan is just 1 over 4, and then this ends up being cos of x minus pi over 2 divided by sine of x minus pi over 2, because that is what cotan is. Remember, tangent was just sine over cos, right? So now this allows us to figure out what our vertical asymptotes are. So you're going to do this. You're going to let sine of x minus pi over 2 equals 0. And when you find that, you get x minus pi over 2 is equal to, well, if you look back on the sheets that I gave you, for the basic graph of sine of x, the zeros are n times pi. And all we do is just solve for x. So you end up with x is equal to pi over 2 plus n pi. And that is what we have for our vertical asymptotes. Now, you can always take a moment and graph this. It's not difficult, but you need to be able to at least calculate the period, the x-intercepts, and the vertical asymptotes, and then graph. So for your homework, you're going to be doing these questions here, 31, 37, and 53. That's all you're doing. This last one deals with absolute value. If you have to, go and use Desmos, and you're going to use the ABS with your function. So if you were doing this one, you're going to do secant of x, and it would give you what we're looking for. And what I want you to do is I want you to compare your work to what Desmos gives you.